is equal to some b to the power of x. And we said b should be greater than 0 and b cannot be equal to 1. So it should be a positive number but not equal to 1. And x can be any real number. We talked about this thing, special, exponential functions. Today we are going to logarithmic functions. Logarithmic functions. How do you denote logarithmic functions? It is basically y is equal to log, and this log will have some base b. This log will have some base b and then x. Note this b is in the base of log. So there will be always a b base. You can write the same logarithmic function. You can write the same logarithmic function in the form of exponential function. So if I say convert this logarithmic into exponential function, how you will do it is, you will take this base, whatever is the base, you will take it on the other side. So it will become b, this base will go on the other side, and whatever was on the other side, that will become the power, is equal to x. So if I say convert from logarithmic to exponential, you should know how to convert. This base here, b, will go there, and this y will become your power, is equal to whatever was here, x, that remains as it is. Example, I give you 2 is equal to log 5x. I say convert this into exponential functions. You have to convert this into exponential functions. How do you convert? This base will go on the other side, that will become your new base, and this 2 will be the power, x. 5 squared is equal to x. That is equivalent exponential function. This and this means the same thing. Okay, let's do one more example. If I say 3 is
Wait,
equal
Miss R, or Miss K,
Yeah.
You want us to simplify?
No.
Nope, okay.
If the question says simplify, you do it. If it says just convert and leave it. Yeah. So you have 3 is equal to log b 64. You have to write the exponential form. Jasmine?
Yes.
What will be the exponential form for this one?
So it would be log.
No. There will be no log in exponential. I have to convert this in.
No. B, right?
No. So what happens is, what's your base here? B, right? Log has the base as b. This b will go on the other side. So I have b here. Whatever was on the other side, that will become your power. Are you getting it?
And then, 3,
Is equal to 64.
64.
Okay, Jasmine, you will help me with one more. So you have log 7 is equal to y. Convert into exponential.
3 and then y equals 7, right?
Yes, exactly. You got it. Good. Any questions, anyone? How to convert from logarithmic to exponential and exponential to logarithmic? Do this problem yourself right now. Try. Convert into exponential. Log 7x.
Miss K?
Yeah.
Somebody isn't muted, so it's kind of difficult to hear you.
Just a second. Can you hear me now?
Yeah,
Okay,
that's better.
perfect.
Thank you.
Yeah, no, sure. So you have 3 is equal to log 7x. This problem, I'm going to give you 2 more. Do this problem yourself right now. Try them yourself right now.
Miss K, that's log 7 for the first one, right?
Yeah, log 7, yes.
Okay.
XQ.
Yes.
What's the answer for the first one?
9 to the third power is equal to x.
Yeah, it's 7. It's okay. If you took 9, that's okay, but it's 7.
Oh, okay.
Yeah, no problem. Good. Jaden,
Yes.
the second one.
It's b squared equals 25.
Good. Okay. Tracy,
Yeah.
the third one.
Y to the wait, is that a 4? Oh,
That's a
4 to the y power equals 26.
Good. Really good. So this is how you convert from logarithmic to exponential. Next thing what we are gonna do is you will be given exponential. You have to write the logarithmic. Example, if I say you are given 12 square is equal to x. I say convert into logarithmic. Whatever is the power that will come down, log is equal to log. Whatever was the base here, that will become the base of the log also. And then x. It's just going backward now. Let's see one more example. If it says b cube is equal to 8. Melanie is okay. Sean,
Yep.
Sean, how do I convert into logarithmic?
It would become 3 is equal to log b 8.
Log b 8. Good, really good. Okay. Kaylee,
Yes.
you're gonna give me for this one.
Would it be y equals log 9e?
Log base e and then 9. Really good. Okay. Let's do one more problem here. You have to 2 to the power of 5 is equal to x. Then you have b to the power of 3 is equal to 27. And then you have e to the power of y is equal to 33. Gabriela, Gabriela,
Yes.
okay, what's the answer for the first one?
Would it be 5 equals log 2x?
Yes, correct. Andrea,
Yeah.
second one.
Would it be 3 equals log v27?
Correct. Mason,
It would be y equals log e33.
yes, correct. So this is how you convert from logarithmic to exponential and exponential to logarithmic. This whole chapter you really need to know how to convert these things from exponential to logarithmic and logarithmic to exponential. Now we're gonna go to the topic is evaluating the logarithmic functions. Evaluating the logarithmic functions. So example, if I say log 216 is equal to, you have to find the value of log 216. What is log base 216? You have to find the value of this thing. What's my answer? Log 216. It will give you some answer. How do you find it is, I don't know what the answer is right now. I say it is equal to x. I say some x. It is equal to some x. What I'm gonna do next is, I'm gonna write this in the exponential form. Carmen,
Yeah.
What's the exponential form of this thing?
Would it be, sorry, hold on. It would be 16 to the power of 2 equals x?
No.
The other way around? I don't know.
So how do you do it is you take this base on the other side. So here 2 was the base of log. So 2 will still be the base of exponential. So it becomes 2 to the power of x is equal to 16. Okay? You got this thing. Next thing what you're gonna do is you're gonna make factors of 16. You're gonna make factors of 16. Carmen, can I divide 16 by 2?
Yeah.
2 times what?
8.
Can I divide 8 by 2?
Yeah.
2 times what?
2 and 4.
4. And then 4 as
2 and 2.
2 and 2. So I got 2, basically 16 I can write as 2 to the power of 4 because I have 1, 2, 3, 4. Since my bases are the same and exponents are different, I get my x is equal to 4. If your bases are the same, so if you have am is equal to an, this will imply m is equal to n. I use this property. If your base is the same and your powers are different, then your powers will become equal to each other. So basically the value of log 216 is 4. Let's do one more example here. So you have log 7 1 over 49. They say you have to find the value of this thing. Okay. Carmen, can you help me? So basically I need to find the value, I put it equal to x. Carmen, convert it into exponential.
7x equals 149.
Yes, exactly. Good. Really good. Okay. What I'm going to do is, I'm going to make factors of 49. I know factors of 49 is 7 times 7. So it is 7 square. Note it is still not the same. It should be exactly, if here it is 7, here it's supposed to be 7. But here I have 7, but here 7 is in the denominator. It's supposed to be in the numerator. There is one more property we are going to use. It says, if a to the power of negative m, if you have a negative number in the exponential, you can make it into positive by taking it in the denominator. So my a will still remain the same. Only the negative will change into positive. You can do that. So in this case, I have 7 square. I want to take this in the numerator. Since my power is positive, it will become negative. Now, since my bases are the same, now if you have a to the power of m is equal to a to the power of n. Here my a is 7. Then your m is equal to n. So you get your x is equal to negative 2. Any questions, anyone? Let's do one more problem.
Why is the what's the importance of like the AM equals AN?
A are any number. A, M, N, they are any numbers. It's just general formula.
Oh, okay.
Yeah, I'm just giving you general formula. Yeah. So that you know when you know you're doing your notes, you're going through your notes, you know how I got this. Yeah. Let's do one more example. So you have log 25 5. I say solve this. Okay. Maximus.
Hi, Miss. Okay, how are you?
Good, good. How are you doing?
I'm okay.
Yeah. So help me solve this one. What's my first step?
Hold on, I'm at a coffee shop. It's really loud.
It's okay.
Wait, is it equal to x?
Yes, you will put it equal to x. Yes.
So it would be 5 to the power of x equals 25.
No, no, no.
Is it the other way around? 25 to the power of x?
Yes,
Oh,
you're-
yeah, that's right.
Yeah, is
25 to the power of x equals 5, and then we have to figure that one out.
Yes. So now, can I write 5 as 25 to the power of something?
I don't know. Probably.
What do you think? Or can you write 25 as 5 to the power of something?
Yes.
What can you do?
I don't know.
25 is what? What are the factors of 25?
5 times 5.
So 5
5
squared.
squared. Oh.
You can write 25 as that thing.
Uh-huh. So
Then
would
here-
it be, this is x negative 2?
2x is equal to what? Same base,
Negative 2?
just 1. Here it is 1.
1?
Are you getting it, Maximus? It does not look like you got this.
Kind of. I was following along for the first half.
Yeah, so it's basically you got this, that's correct. But then next, what you're gonna try to make is, you want to make your base same.
I see.
Now
That
since your base
kind
is
of
same,
makes a little bit more sense.
yes, you put your exponent same and divide it by 2 because I just need x value. So you get x as 1/2.
Okay.
Yeah. You're gonna help me in another problem. Let's see here. So you're given log 2 fifth root of 2. So how, if I say solve this, you will put it equal to x yourself. Okay. Convert this into exponential, Maximus.
2 to the power of x equals,
Fifth
how do you say
root of
that?
2.
5 root 2.
Yes. How can I write fifth root as in a fraction? See here. Square root I can write as whatever. Suppose I have to find square root of x. It becomes x to the power of 1/2. If I have to find cube root, it becomes x to the power of 1/3.
So would it be x to the power of
What is
1
here?
over 5?
What's the x here?
The x here is 2.
So it becomes 2 to the power of 1/5.
1 over 5.
So what is your x value?
1 over 5? I don't know.
Yes, exactly. It's
I'm
1/5. That's correct. Base same, different exponents. You put them equal to each
Okay.
other.
Same base, different exponents. Okay.
Yeah. Any questions, anyone? Try these problem yourself right now. I'm gonna give you. Yeah.
I have a question. So how do you go from 2x to x while you're doing the right side? Like, how does that work?
So I'm converting into exponential functions. Logarithmic is given, right? I'm writing in the form of exponential. So how do you write it is this 2 will go the other side. It will become 2 to the power of x. And this, you know how to convert from logarithmic to exponential? Go. Yeah, you got it or you did not get it?
No, I understand it. I'm just like, it just doesn't make sense to me how I kind of get it.
Yeah, it's just the equivalent form. That's how you convert from logarithmic to exponential and exponential to logarithmic. There is no, explanation of how it came.
Okay.
Yeah. Try this problem. I want you to find the value of this thing. Log 5, 125. Then you need to find value of log 36, 6. And then you need to find value of log 3, seventh root of 3. Do these 4 problems right now. Nikhil?
Miss K, that third one says 36 or 56? 36, right?
Third one, 36, 36. Faith,
Yeah.
what did you get the answer for the first one?
I got x equals 10.
So how did you do it?
So I put the equation equal to x,
Then what did you get?
and then I got 10 to the power of x equals 100,
Okay.
and then 10 to the power of x is equal to 10 to the power of 10.
10 to the power of 10?
Oh, wait, no, 2.
2. Yes.
So x equals 2.
Yes. X is equal to 2. Really good. No. Cole Raymond,
Yes.
for this problem, what did you get?
Okay, for the setup of the problem, I got 5 to the power of x is equal to 1 over 125.
Okay. Then?
And then for that, I just got to that part right now, and I'd assume, would you have to get rid of 5 from the left side? So would you do divided by 5 by both sides?
No. So 5, what you have to make is, what you're trying to do, Cole, in this case is, you're trying to
Okay.
make the same base. Like here we did 10 and 10. Here I have 5. I need to make this also 5 to the power of something.
Okay.
How do I do it? Can I write 125 as 5 to the power of something?
No.
Now let's make factors of 125. Can I divide 125 by 5?
Yes, you can divide 125 by 5,
Which is 5 times what?
which is 5 times 25.
Okay, 25. 25 can I divide by 5?
Yes.
5 times 5, right?
So it's 5, 5, and 5.
So 5 to the power of 3.
5 to the power of 3.
But note,
So-
it's in the
So then
denominator.
your answer is 3.
If I take in the numerator, what does it become?
5
To the
to
power
the
of?
power 5 to the power of 3.
No. It's in the denominator. You have to
Negative.
change the sign. Negative 3.
Okay.
So what's your x equal to, Cole?
Negative 3.
Perfect. Really good. Cole, Adam,
Yeah.
let's do this problem.
For the next one, I got 1/2, but I'm not really sure about it. So if you could walk me through like the
Yes.
steps on that one too.
So yeah, you got the answer correct. Answer is
Okay.
not wrong. Your answer
I
is
think I know
correct.
how to do
But let's see how you did it.
it. Okay. So I had 36, and then I factored that, so it's 6 and 6. So it's
No,
6 squared.
first write in the exponential form.
Okay. 6 to the power of x is equal to, or no, 36 to the power of x is equal to 6.
Okay. And 36, can you write 6 to the power of something?
Yeah, you could do 6 squared.
Yeah, 6 square, and then there was already x, so it becomes 6 2x is equal
Yeah.
to 6. So what do you get?
So then it is 1/2.
So
Because-
2x is equal to what? See, what's the exponential? What's the power here? If it's nothing, it's 1.
What? Yeah.
x6 is raised to power. If there is no power, there is 1 there. So I get 2x is equal to 1. Then you divide it by 2 both sides, you get x is equal to 1/2. That's how you got it. You got the answer
Okay.
correct, but you have to show these steps, okay?
Okay, thank you.
Good. Melanie? She's there, I guess. Jacqueline? Is Jacqueline here? My pen is not working. Jacqueline not here. Benjamin? Benjamin not here. Jamie?
Yeah.
Okay, Jamie, the last one.
Do you want me to walk you through the whole
Yes.
process?
Yes.
Okay, so I put 3 to the power of x equals
7th root.
7th squared 3.
7th root of x.
Seventh root 3.
Yeah.
And then I put 3 to the power of x equals 3 to the power 1 over 7.
Okay.
and then x equals 1 over 7.
Really good. Really good. That's your answer. Any questions, anyone? So this is how you're going to solve exponential functions if they ask you to find the value. Okay. Next thing we're going to do is properties of exponential function. Properties of exponential. So next 2 sessions, today and the next session, is all about, sorry, not exponential, logarithmic. So today and next section is all about properties of exponential functions. So the first property today, what we're going to do is, if you have some log, some base b, remember my log and my base is b, and then here also I have the same b. My base and my number, whatever I have here, they're exactly the same. It will equal to 1. You don't have to solve anything. You should know yourself directly. It will be equal to 1. Example, if I say what's the value of log 2, note my base and my number here are exactly the same. Since they're exactly the same, I know my answer is going to be 1. The second property is, if you have some log base, and here you have 1. No matter what your base is, I don't care what my base is, but if you have 1 here, it will always be equal to 0. It will always be equal to 0. Example, if I say what's the value of log 100, 0. You don't have to write it in the form of exponential, oh sorry, not 0, 1, sorry. You don't have to write it in the form of exponential. You directly should know, if you have log any base 1, it will be always equal to 0. If they are exactly the same, it will equal to 1. If your base is different and here you have 1, if here you have 1, it will always be equal to 0. Example, let's do examples here. If I say find the value of log 7, 7. Log 7, 7. Alexander?
Yeah.
What's the value of log 7, 7?
It's just 1.
It's just 1. Correct. When your base and your number is exactly the same, it is always equal to 1. Jaden?
Yes.
Log 5, 1. What's the value of log 5, 1?
0.
0. No matter what your base is, if you're finding log 1, it will always be equal to 0. Good. Minhan?
Yes.
Okay. Minhan, so let's see, if I say find the value of log 9, 9.
That's going to be 1.
1. Correct. Okay, Minhan is there. Cameron?
Yeah.
What's the value of log 8, 1?
0.
0. Correct. No matter what my base is, it's always equal to 1. I want you to make a note for yourself. Important note. This is very important here, what I'm writing here. If I say this, writing this base is very important. Writing the base here is very important. Don't forget to write the base, because if you don't write the base, if suppose I say what is log 10, find the value of log 10. If I don't write the base, it actually means there is a base. You know what is a base? 10. If nothing is given as a base, generally it is assumed that your base is 10. So if I say find the value of log 10, okay, Jamila?
Yeah.
So if I ask you find the value of log 10, what is the value of log 10?
1.
1. Because if there is no base, there is a base already 10. And if they are the same, your value is 1. Correct. Very important note, guys. If there is no base, that means the base is 10. Also, I want you to, if you want to write the second property here, it says there is something known, there is a special kind of log which is ln. ln. If I say ln 10 something, you know this special kind of log, this ln, what does it mean? It means log and my base is e. This is special kind of log. ln means log base e. If it's just log, that means log is base to 10. If they say ln, that means my log is base to power of e. So if I say find the value of ln e, I say find the value of ln e. Kylie here?
Yes.
Okay, Kylie. You need to find the value of ln e. How will you find it?
The value would be 1 because ln is log base e, and then e would be
1.
your other b.
Yes,
and
exactly.
the value is 1.
Exactly, really good, because your base and this are exactly the same, so it is equal to 1. This thing, make sure you remember this. In this whole chapter you will be using these two. Don't forget these two things, very important. Okay, another thing is, okay, let's do another property. So we did 2 properties so far. First property we said is log b, if they are exactly the same, then your value is 1. Next property we did is, if you have, no matter what your base is, if you're finding log of 1, it will always be equal to 0. Third property it says is, if you have log b, now b, and this b is raised to power x. Note you have now b to the power of x. Basically everything cancels, you're left with just x. So if I say example, if I take for this example is, if I say find the value of log 2 to the power of 5. Since I have here 2, my base is also 2, and then here also 2 is raised to power 5. In this case they cancel out, you're left with just 5. Also one more property is, if your b is raised to power log, bx, b is raised to power log bx. Now my this base and my this base of the log, the base of the exponential and base of the logarithmic, they are exactly the same. They cancel, we are left with just x. So if the base of your exponential and logarithmic, they are exactly the same, they cancel out, you are left with x. So example, if I say what's the value of 5 log 5 8, I say find the value of log 5. Since my base are the same, they are real good. Evander left. Okay, Gianni.
Yes.
Okay, Gianni, the next example is 6 log 6 9.
It would be 9.
9. Really good. Leah.
Yes.
What is log 7 to the power of 10?
That would be 8.
Really good. Cameron.
Yeah.
Log 3 7. 7. Good. Any questions, anyone with these properties? Okay. Maximus,
Yes.
what's the value of ln e to the power of x?
ln e to the power of x, you said?
Yes.
Hold on, I'm looking at my notes. I don't know, you're gonna have to help me through it.
Okay. What is ln, Maximus?
It's the special
Yeah,
log.
which is basically what? Log to the base of
E.
e. And what is log e to the power of x?
X.
Exactly.
I see.
Yeah, exactly the same. Yes. Okay, let's do one more example.
Thank you.
Jamila,
Yeah.
if you have e to the power of ln x, it is equal to what?
Sorry, can you say that again, or can I just see it written down? I don't know.
What is ln?
The log base e.
Yeah, log base ex. So what does it become?
Oh, base e and 1.
So which property are we using? These are the 4 properties I've written here. See here, 1 here, 2 here, 3 here, and 4 here. What does it look like?
Oh, it looks like the. Oh, is it x?
Yeah, it's just x.
Okay.
Any questions, anyone? Okay. Do these problems, the problems I'm writing here, make sure you write these problems yourself. Okay, do it yourselves. Write the exponential form. A log 216 is equal to 3x is equal to 32 6 16 is equal to 8. Start doing these problems yourself. Start doing these problems yourself. If you do these problems and you get the answer by yourself, you understood the today's concept like really good. Leah?
Yes.
Did you get the answer for the first one?
The first one would be 2 times 4 equals 16.
Perfect. Yes, really good. Gianni?
Yes.
Second one, what did you get?
3 squared equals x.
Yeah, good. Aiden?
Yeah.
What did you get for the third one?
B to the power of 5 equals 32.
Yes, really good. Jasmine?
I got b to the power of 4 equals 216.
6 to the power of y is equal to 216. Good. Kylie? This one.
We're on A for logarithmic form. Yeah. I got 3 equals log base 2 8.
Yeah, really good, Kylie. Really good. Jade?
I got -3 equals log 5 1 over 125.
Really good, Jade. Jamila?
We're on C, right?
Yeah.
I got 2 equals log 13x.
Yes, really good. Yes. Jamila. Cameron?
Yeah.
What did you get here?
Which one are we on? Sorry, I can't see. It's kind of laggy right now. Oh, A for evaluate.
Yes. Yeah.
I got 4x equals 16, and then x is equal to.
Okay. Solve and tell me what you get your x as.
Oh, x equals 2.
X is equal to 16 because you can write as 2 and then it becomes x is equal to 2. Really good. Execute.
Yes.
How do you solve this one?
That one would be. I don't know how to get there.
Just think whatever you just tell me. If you think whatever you think, just give me an answer. I want to see how you're thinking. So execute. I put it equal to x. Okay. I put it equal to x. Write the exponential form. What's the exponential form? Execute. What's the exponential form for this thing?
I don't know.
We've been doing problems. All these problems we've been doing, you did not understand the lecture at all?
No, I got it. I just didn't have time to do it.
Oh, see here. It's like, if you have to write the exponential form of this thing, what do you think is the exponential form? See, here we convert it from here to here. I want to convert this thing into exponential form.
It would be 5x is equal to 1 over 5.
Exactly. Yes. I have here 5. I need to take this in the numerator. How do I take it in the numerator?
Whatchamacallit? You split it up, the 5 but it's only 5 and 1. So it would be 7x is equal to 5 to the first power, but then we would change it to negative, so it would be 5 to the negative first power.
Exactly. So what's your x equal to?
-1.
Perfect. You got it yourself. You did it yourself. Really good. Execute. Minhan?
Yeah, I'm still doing it.
Yeah,
so,
sure. Take your time. But you're going to help me with this one.
Is that square root 7?
Yes, it's square root 7. Yes.
It's going to be 7 to the power of x equals square root 7. And then that is going to be 7 to the power of 1/2.
Yes, exactly. Yes.
So x is equal 1/2.
Really good. Yes. Jaden?
We're on D, right?
Yes.
Okay, so it's equal to 1.
Same base and the same number. It is exactly equal to 1. Alexander?
Sorry, yeah, what's up?
E part.
Oh yeah, that's when it's equal to 1 is 0, right?
It's 0, exactly. You don't even
Okay.
have to solve. You directly know it is 0. Jamie?
Yeah.
What about this one? Log 5 to the power of 7.
7.
Really good. Yes. Tracy?
That would be 19.
Yes. Good. Benjamin? Not here. Jacqueline? Not here. Melanie? She's not here. Sean?
It would be x is equal to.
Okay, you're saying
Oh,
it's...
wait, or h, right?
Yeah, H part, yes.
Yeah, x is equal to.
So here, let's see here, Sean. Okay. What's my base here?
10.
10. Okay, log... Okay, you're saying it's equal to x. Okay. So what do you get?
You get 10x is equal to 100.
Okay. Then?
And you take out, and it would become,
Either you have to write 10 as 100 to the power of something, or 100 you have to write 10 to the power of something.
So it would be, that would be 10 to the power of 2. The 2x is equal to 1.
X is equal to
2.
2. Because 100 you can write as 10 square, right?
Yeah.
Yeah. Good, Sean. Okay.
Oh, I was, okay.
Cole Adam. Cole Adam, not talking. Okay, Cole Hartman.
Yes.
Okay, what's the answer for the I part?
For the I part?
Yeah.
1 second. I was on G, so I'll be a second.
Yeah, take your time. It's okay.
Miss K, for G is it's just like it says log 8 equals 19, right? That's the,
No, it's not log
the,
8. It's not log. There is no log. It's 8 log 8 19.
Okay.
So for I, would your format of the question it'd be 10x?
Wait. Cole Hartman, first you tell me here, what's my base here? If it's nothing.
It's nothing. Would your base be 1?
No.
Would it be 0?
See here, we did here. If nothing is written here, it means my base is 10.
The base is 10?
Yeah, if it's ln, that means my log base is e. Okay, you have to remember these special two kinds of logs.
So would that mean it's 10 to the power of 10?
Yes, it's log 10 to the power of 7.
Log 10 to the power of 7. Okay.
See if you can use any property in here.
So is 10 still your b? Or is it 100?
So it's log 10 to the power of 7, right? I have 4 properties here. Which property can you use?
Well, if our equation is b to the power of y equals x, that we have to look at.
So whenever you have your base, this base and this number exactly the same, okay? And there
Okay.
is some part. They basically just cancel. Your answer will be 7.
7?
Yeah.
So your base is equal to 7?
Yeah. No, not base. Base will always remain 10. If there is nothing, the base was always 10.
Okay.
They just, since this and this base are exactly the same, right? They
You
cancel.
just cancel out and then it's your x value?
Yes.
Okay.
Kaylee,
Yes.
what's the value of this one?
Wouldn't it just be 33 because it's in the exponent?
Yes. What's my here base here?
Would your base would be, wouldn't it just be 33?
Base here. X log to the base. What's my base here?
10?
10, yes. If nothing is there, it is 10.
Okay.
Now, it's not like, oh, it's in the part, that's why it is equal to 33. No. It is equal to 33. The reason is this base, my exponential base, this is the base of the exponential, and the base of the logarithmic, they are exactly the same.
Okay.
Yeah. Good. Okay. Faith,
Yes.
what is ln e to the power of 6?
ln e to the power of 6 is equal to 6 because the base for the logarithmic ln is e.
Yes, so it becomes ln e to the power of 6 and they cancel, you're left with just 6. Really good, Faith. Maximus?
Yeah.
ln 1 over e to the power of 6.
I'm not there yet. Give me a second.
Okay, do it the L part. First of all, I'll help me do this. Walk me through. What is ln?
Log e.
Log e. Okay. Now I need here e to the power of something, but my e is in the denominator. I want to take in the numerator. What do I do?
Multiply.
No. E to the power of what? Here I have e to the power of 6. If I take in the numerator, what does it become?
6.
It's 6,
Again.
right? Is it 6, right? You change if it's positive, make it negative. If it's negative, you make
Yes.
it positive.
Negative 6.
Negative 6. So now what is it equal to?
Negative 6.
Exactly. Yes. I again repeat, if it's in the denominator and you have to take in the numerator, e will still remain the same, e. Only the power of the sign of the power will change. If it's positive, it will become negative. If it's negative, it will become positive. Carmen?
Yes.
What's the value for this one?
I don't know if I did it correctly, but is it the square root of x?
So, yes, you got log 10. How can I write square root of x as x to the power of?
X to the power of 1/2.
1/2. What's my base here?
10.
10. What is it equal to? Log 10 x to the power of 1/2.
Mhm.
It will be equal to
1/2.
no, this whole
Then
thing.
I
This
don't
whole
know.
thing. Basically, this 10 and this 10, these two bases cancel out.
Mhm.
And you're left with x to the power of 1/2. Any questions, anyone, with these problems we did? Okay. Few more problems and then we are done with today's lecture. Okay. See here. So you have to find the value of log 3, log 7, 7. Then you need to find value of log 5, log 2, 32. You need to find value of log 2, log 3, 81. Log ln e. These are the 4 values you have to find right now. Can I have Jamila?
Yeah.
Let's solve. Log 3, I want to solve the bracket first. What is log 7, 7?
1.
1.
Right.
Again. Exactly. So I replace log 7, 7 with 1. What is log 3, 1?
It's 3 to the power of 1 equals x.
No. It's a direct property.
Oh. Oh, it's 0.
It's 0. No matter what my base is, if I'm finding log of 1, it will always equal to 0. Correct. Okay. Execute.
Yes.
Let me solve the inside bracket first. Log 2, 32. I need to solve this. Log 2, 32. I keep log 2 as it is. Can I write 32 as 2 to the power of something?
Yeah.
Which is, let's make factors. 2 times what?
What? 11?
Make factors of
16.
16. 16 is 2 times?
16 is 4. 8. Alright.
Yeah. And then 8 is 2 times?
4.
4 is 2 times?
2.
32 I can write 2 to the power of what?
5.
5. Okay. What is the value of log 2, 2 to the power of 5?
25.
See the properties. What does it become? It is equal to?
One.
No. You said your answer correct before. What did you say the answer is?
25.
Not 25. Log 2, 2 to the power of 5. See, these are the properties here. Let me show you. These are the properties here I have, which I've made a box on it. So these are the 4 properties I have. What do you think? Which one does it look like?
The answer is 5.
5, yes. And what is log 5, 5?
5.
Use again the property. See which property does it match? My this and this are exactly the same. When they're exactly the same, it is equal to?
1.
1. Exactly. You got it. Good execute. Cole Hartman. Cole Hartman here?
Yes.
Okay, Cole Hartman. So let's do this one.
Okay. So right here you have equals log to the second, and then you have to break down 81 into its terms.
Okay.
Which is 3 and
27.
27. Okay. then you have to break that down into 9 and 3, and then 3 and 3.
So 81 is basically?
So then you get log 3, and then you have to put 3 to the power of 4.
4, okay. You get log 2. What is log 3? 3 to the power of 4.
That would equal log 2 equals 1. Or
what is the value of log 3? 3 to the power of 4. See, these are the 4 properties. What does it look like? This property looks like which one? This, or this? Log some base and this base to the power of something. What does it look like?
Oh, it would be, wouldn't it be 4 or would it be 3?
It would be 4. The property, this one. When your base and this base are same, they cancel out. You're left with just x. Okay, you got this thing. What is log 2, 4?
Wouldn't it be?
Can I write 4 as something 2 to the power of something?
One, 2, 4.
Let's make factors of 4. What's the factors of 4?
1, 2, and 4.
Yeah, 2 and 2, right?
1, 2. Yeah, 2 and 2.
So it becomes 2 square. What is log 2, 2 square?
Four. 1. Wouldn't it be 1 since?
See here, they use this property and tell me what is it. Log 2, 2 square. See here.
I don't necessarily understand what I'm like supposed to be answering or like what I'm doing. Would it be x?
X. What is x in this case? It's a power here. It's a power here, which is 2.
2.
Can't you just like easily do just log 2, 4, and then just get 2?
Yeah, you can do that. So here, Cole, you tell me these problems, okay? You're gonna help me solve this. What is log 10, 10 to the power of 8? Cole.
Talking to me still?
Hmm?
Okay. So would that be 10?
So you have a property where you have log base and your same base is raised to power x, okay? When it's like this, they basically cancel out. Whatever is your power, that will be your answer. Okay. In this case, my base and these two are exactly the same, right? Here I have log base 10 and then here I have an exponential function with base 10 to the power of 8. They're exactly the same. So they cancel, you're left with 8.
Okay.
You tell me what is log 2, 2 to the power of 5.
Log 2, 2 to the power of 5. It would be 5 since the 2's cancel out, correct?
Yes. What is ln e to the power of 6?
Ln e to the power of 6. Would it be 6 because you're ln? Or
ln is
do
what?
your ln e, do those cancel out or no?
What is ln basically? Log with base?
I don't remember that equation, the ln e.
Ln e, yes. Ln means log with base e. Okay. So it becomes e ln this thing. Okay. Now what is it equal to?
Log e of e and then 6. So your answer would be 6.
Exactly. Are you getting it now?
Yes, that makes sense.
Okay. Can I have Cameron?
Yeah.
Okay, let's solve this one. Log, what is ln e?
It would be, it's ln e and then, or log e and then e again.
E, which is basically
1.
1. And what is log 1?
That makes it 10x equals 1, right? If it was log 1.
What is log 1? What's the value of log 1?
Sorry, I'm looking at your notes. Hold on.
These are the 4 properties we did. It's equal to 0. No matter what my base is, if I'm finding log of 1, it is always equal to 0. Any questions, anyone, for today's lecture? Make sure you practice these problems, these 4 properties here we did. You should remember these property really good. Also, you should remember that if you have just log, it basically means log with base 10. If they say ln, that basically means log with base e. These are the 6 things we did today. Make sure you remember this, because next lecture I'm gonna teach you more properties, and it's gonna be combined. With those properties, you have to combine these properties. So it's gonna be a lot more properties. So make sure you remember these. Okay. Any questions? Anyone with this lecture can stay back. Other than that, that's it for the today. Thanks, guys. Have a nice day. See you on Thursday.
Thank you, Ms. K.
Take care. Welcome. Take care, guys. If you have questions, please stay back. Yes, Jade, you have a question?
Not about this. I understand this. It was just about like my grade. So Max can go first, and I can just wait.
So maybe I want to meet like separately for. So Jade, can you maybe Maximus?
It's okay. Jade can hear my question. I don't care. I trust her. She's my friend.
Okay. Perfect then. Perfect. Yeah.
Yeah. Then I can go first. If Jade wants to keep it sensitive, then that's fine.
Okay.
Remember, when I'm telling you, Miss K, I really thought that was the right thing. I thought that the quiz was the exam, and then I sent you the homework, and you were like, "Great job, Max." So like in my brain, I was like, "Oh, I did a good job. That was the right one." And then you told me, and I was like, "Wait, what?" So I was like, "Oh shit!" I was so like.
It confused me too. It confused me.
It was really confused.
When you sent me the work, I was like, "Oh, okay." He's like excited about his quiz thing. I was like, maybe I thought also that time maybe he's confused, but then I was like, maybe he just wanted me to see the work.
I thought that because you asked me to turn in the work for the exam, so that's what I thought. I thought it was. So, is there like any way that I can redo it or something? Because I know it probably is locked or what.
So for you, I know. Okay, that wasn't. I know genuinely because yours was not an excuse, and yes, that happened because you sent in me the notes for the quiz. I will assign you the test again.
Okay, so when should I do it then? Can I do it on the weekend, or because I work and it's kind of hard.
When are you free to do it?
Do the weekends work for you, or do you like to keep your weekends off?
Okay, so let's do it on let's see, Saturday. Saturday works?
That works for me, yes.
Okay. So Maximus, but you have to do me one favor on Friday evening or Saturday morning. You have to call me. You have my contact number, right?
No, I don't have your phone number. I only have